Hello friends, today we are going to learn graph coloring problem. Okay, so first we wanted to see that what is graph coloring, right, and why it is required. So generally when you are saying that graph coloring, we are feeling like that we are going to color the graph. But in realistic life you can see that there is a different kind of map. You can see that, right? Map are colored with a different color, right, and it looks beautiful. So if you'll ask somebody, there are 10 vertices, right? There are many edges, so we'll get many regions. So when you're talking about the graph coloring, doesn't mean you're going to color the vertex. We are talking about the region of that particular graph. So in one graph you have 10 different regions. All the regions are going to color with the colors, right? So how many different number of colors you are going to use to color those graph is graph coloring problem. So remember, if number of colors are more, we can use for each and every region different color, right? But if question is what will be the minimum number of color to be used to color the graph, such a way that adjacent region should be not colored with the same color, otherwise it looks like this is the part of the same region, right? So adjacent regions must be colored with the different color. It means we should have edge where edge is having a adjacent region, both the regions should be colored with a different color. So if there are, say that 5 different regions and you have 5 different colors, there is no problem. But is it possible to color with less number of available color, right? And if yes, if you are able to make it, the minimum number of color to be used to coloring the graph is called chromatic number. So let us see that how you are going to address this and how you are going to solve this graph coloring problem. So graph G can be colored in such a way that no two adjacent nodes have the same color, yet only M colors are used. This is called M coloring or N colorability decision problems. If D is a degree of given graph, then it can be colored with D plus 1 different color. Now, when you are talking about the degree of node, right, then it's called in that particular node how many incident vertex edge and how many outgoing edge you have, in degree edge and out degree edge, right? So that is called degree of the node. Total degree is what? In degree plus out degree, right? It's called degree of node. When you are talking about the degree of graph, it means maximum number of degree present in nodes present in that particular graph. Maximum number of degree, right? Say one node is having degree 2, second node is a degree 3, fourth node is a degree 8, right? So on, right? Again last node is a degree 1. So among these, what is the maximum degree? Is called degree of graph, right? Again I will repeat, degree of graph is a sum of in degree and out degree. It means how many number of edges are incident on that particular vertex and how many edges are going out from that particular vertex. M colorability optimizations problems ask for a smallest integer m. That is, a smallest integer m means what? We are talking about the minimum number of color to be used, for which the graph G can be colored. This integer is referred as chromatic number, right? So let us see one by one how you are going to address this and what will be the chromatic number, what will be the minimum number of color to be used by using backtracking concept. Say, if there is one vertex, right? So there is no issues, all regions are same region, right? If you have, say, which kind of graph it is? Planar graph, right? Say this vertex is one region, this vertex is from other region, this vertex from the third region, right? So this is basically three different regions point. How it is? Say here we have different region, right? Okay, we have different region 1, region 2, region 3, right? Say here we have region 4. So what will be minimum number of color to be used, right? We can see that one color we can use here, second color here. We cannot use the same color in both the place because adjacent edge, right? Having the same adjacent edge for the both the regions, right? Common edges are there between the regions. So we will have different color. But here we can use the first color, right? That will be minimum number of color used. So basically here 1, 2, 3, 4, 4 different color can be used to color the graph, right? But what will be the minimum? I can go with color 1, here I can go with color 2, again I can repeat color 1, and here you can repeat color 2. So basically we can use two different color only to perform the task. Minimum number of color to be used 2, right? So this 2 is called here chromatic number. This 2 is called here chromatic number, right? Similarly, this is just similar kind of graph I am talking, where we have different regions, one point. So if this region is colored with what 1, this is adjacent, region, right, vertex. Hence we have to color with a different color. So we have colored with the 2. Since this node is also adjacent to this first, right, and this is adjacent to the second as well. So we cannot use the second. Region is first. We cannot use the second here because it is connected with the second as well. So this should be unique compared to 1 and 2. Hence, which color? How many colors we are going to use? 3 color to be used in this particular case. So we can see that 3 regions we are using 3 different color because all the regions are adjacent to each other. Hence 3 color to be used. Here you can see that more regions we have, 4 regions we have, but 2 color we are able to manage, right, to color the graph. That 2 is here called chromatic number. Similarly, say here we have pentagon, right? Look, if you are able to color in this, right? So say what is the degree? Now I am going to discuss degree as well. So if you will go and see the degree of this node is, what is degree of this node? 2. Degree of this node is 1, 2, 3. Degree of this node is 1, 2, 3. Degree of node is 1, 2, 3. Degree of this node is 1, 2, 3. So what is the degree of graph is maximum degree 2, 3, 3, 3. Hence degree of graph is 3. So as per that given statements, number of color to be used for this particular graph must be 3 plus 1 is 4 different color should be used to color the graph, right? Now let us see, and we are going to perform the task how we can use the lesser number of color. Say we are going to use first color. So definitely you have to use here second color because adjacent. This is adjacent to this one and it is adjacent to the second color point as well. So this must be the third, as we have done with the triangle part, third. Now to look at this point, this is adjacent to 1, adjacent to 2, but not adjacent to this particular node. Hence this color can be same as 3, right? Because it is not internally connected. If it is internally connected, then you would have used different color. But here it is not connected. Hence we can use the same color. Now come to this particular vertex. Since it is not connected with 1 and 2, it is connected only with a color 3, not connected with color 1 and 2, then you can use here either 1 or 2. Any color can be used. So based on this graph, we can use how many colors? 3 different colors to perform the task. 3 different colors, right? But as if we'll discuss based on the given concept, if there are number of nodes are 5, then it should be used d plus 1. Let us see that. If d is the degree of the given graph, then d plus 1 color to be used. And as I said, your degree of this particular vertex is 3, a degree of the graph is 3, so 3 plus 1, 4 color to be used. But we are able to manage in 3 color, right? So this 3 is called chromatic number. So chromatic number of this graph is 3. Chromatic number of this graph is 2, while chromatic number of this triangle shape is 3. Now let us see how you are going to perform the task by using backtracking. Basically, what is this? This is the concept of backtracking. We are going to perform the task one by one, and we are going to see that how many different color can be used. So let us see that how you are going to perform this using backtracking. Backtracking concept says we are going to apply depth first search, and we are going to perform the task seeing that, right, whether able to get any feasible solutions or not. If you are not getting it, we will go and do the backtracking, right? So say, as for example, if we are starting the journey from the beginning, right, and say here we have 3 coloring, it can be go with x1, right, x2, x3. Similarly, after this, again we have possibilities, maximum possibilities, right? Similarly, here also we have cases, here also we have cases, right? So we are going and performing the task. If it is 3 different color, we'll go till 3 depth, right? If more number of colors are there, we can use more levels in the trees. So let us see, if first one is x, it's already been colored x1, then next can be have 2 options, right? It can go with x2 or x3 because it's directly connected, right? It should be x2 or x3. In that case, either you are going to use x2 or x3 here. Then again next will be, if you have used x2, if you have used here x1, x2, then you can use x3. If you have used x1, x3, then we can use x2, and along with this, even you can go with x1 because that region is not connected. In that case, we can use the previous level of colors. Likewise, we can do, since x2 is used here, x3 is used in the x2 is used here, we can use here again x2, right? Here x3 is not used, we can use here x3. So we can use minimum number of color for each and every level, and hence that is why there is a famous coloring example is 4 coloring graph, right? It means what? Maximum number of color to be used 4, right? So here what will happen, in each and every steps we are going to find how many different possibilities of colors we have it, right? Accordingly you are going to perform the task. As I said you here, we started from here. Here we have what? We started with the beginning, first color, right? Now say here we have already done with red color, right? Now here we cannot use the red because it is a adjacent vertex. Here we cannot use the red. It is adjacent vertex of that particular region. Remember that when we are talking about the vertex, you take real graph map, right? You take map you have many regions. Each and every region you put one vertex and connect with each other, right? Thereafter you can consider this vertex as a each and every region as a one vertex and give that color. So basically red is a color, is not for this particular vertex, it is for that particular region where this vertex is present. So red. If you are here, you have put up red. Now we can go with green. Can we use green here? No, because it is also connected with second and third node is connected, right? So we have to go with a different color. So red, green. Say here we go with yellow. Now remember that this particular vertex is adjacent to red, adjacent to green because it is connected directly, but not adjacent to the vertex or region is colored with yellow because there is no connectivity directly. Hence we can use any other color except red and green. But since yellow is already been used in the graph, we are going to use same color, right, such a way that you can use the minimum number of color. So let us see, this is again you are going to use yellow for this particular region. Now red is been used, green, yellow is used. Now we can see that last vertex is connected with two adjacent vertex, two adjacent region. That color we cannot use. Then we have to see that what are the available colors we have, right? We can use or not. So we can see that vertex 1 and 2 is not directly connected with this particular new vertex. Hence either you can use the red or you can use the green. So we can use here for this particular vertex or this particular region, either you can use the red as well as we can use green. So there are different possibilities, right? We got different solutions over here, right? But total number of colors are remain 3, but we got 2 different solutions for this, right? So I hope you understand this graph coloring and how you are going to use the minimum number of color. So remember that that smallest integer, right, is called here chromatic number. Minimum number of color to be used to coloring the graph is called chromatic number, right? Now remember that one more thing, if it is a planar graph, right, planar graph, say here we have straight line is a planar, triangle is a planar, right, a square planar graph, we are connected diagonal, it is remain planar graph. If you are putting this cross, then it is not a planar. Remember that more than one edge should not intersect each other, right? In that case those kind of graphs is called planar. So here if you wanted to connect this, we can go and connect like this, right? It is remain considered to be planar graph. Similarly, after that, this is called 2 vertex. We have 3 vertex. Here we have 4 vertex. So this is considered to be K3. This is called K4 graph. All are planar graph. Now talking about the planar graph, minimum color to be used based on the degree. So here degree of each and every vertex is 3. Hence number of color to be used as a 3 plus 1 is 4 different color. Here degree of vertex is 2, 2, 2. So number of color to be used 2 plus 1, 3 different color. Right? Here degree is, since here degree of this particular graph is 2, hence number of color used 3. Here degree of graph is 3, hence number of color to be used is minimum number of color. When I talk about number of color to be used is minimum number of color. We can write it, minimum number of color to be used is 3 plus 1 is 4, right? So that minimum number of color is called here chromatic number. Here what is the degree of node? 1 2, right? Degree of node is 1, here is also 1. So if degree of graph is 1, then number of color will be used 1 plus 1 is 2. So when you are seeing these two straight line, now a person can see that it is the same color can be used in, right? No, it is not like that. What I said you that point what we are talking is in different region, right? How it is, say here we have this kind of graph. This is one region, this is another region. So we kept one point in this particular region, one point outside region and connect it. So basically what it will give you? It will give you one straight line. So here we can take outside, we leave it as a white color, this you can color it with the black color, right? So how many color is required? Outside one, inside one, so 2 colors. So that is why this straight line is represent connectivity, that edge is connected between two different regions, right? Similarly this is edge is connected between 3 different regions, right? So here don't consider that vertex or node is ordinary graph vertex. It is represent each and every node, each and every vertex represent a region. Okay, so this is all about your graph coloring problems. Remember that again you have used the backtracking concept to find all feasible solutions. It depends on the given graph scenarios. We have to find how many different way we can color the graph. So definitely based on the given possibilities, given number of colors, will be having different way of coloring the graph. Maybe one person will start coloring of the region 1 with the red, second person will start coloring with the green, third one will start coloring with the yellows, right? And maybe everyone will take the same number of colors or little bit different number of colors to coloring the graph. There is no problem at all. Intention is to color each and every region uniquely, right? Such a way that there is no problem with respect to identifying the region, right? And if you are using the less number of colors, then it is called chromatic number, and it is also considered to be cost effective, right? So thank you very much for this. We'll meet you again in the next session.